Welcome to the R Crypto Talk show. Today we are excited to have Clifford Mapp, the global head of ecosystem development and information security at Dynex. Clifford is a recognized authority in blockchain and IT security, and his work has been instrumental in shaping Dynex's secure and innovative ecosystem. From ensuring platform integrity to guiding their recently launched wrap token 0xDNX on Ethereum, Clifford's expertise continues to drive Dynex forward in the quantum computing space. We are thrilled to dive into his insights on blockchain security and the future of quantum tech. Welcome, Clifford. It's great to have you here. How are you doing today?
Thank you for having me. I'm doing well, thank you.
Absolute pleasure to have you here with us. I guess, Sahil, we can start off with a few questions and dive into what Dynex is all about.
Yeah, sure. As Tanishq mentioned, let us start off by talking about the overview of Dynex. What are its USPs? What exactly is your role in the project for all our audience and viewers who have not heard of the project before?
Yeah, I mean, probably the best way to start right at the beginning. So Dynex has been around for a while. Obviously, we've been available on a chain for around 2 years, but before that, there was 2 years of hard development from a very small core team. But the core team very quickly realized that Dynex, if we were ever going to go the full quantum route and utilize an emulated quantum system, very similar to how D-Wave and certain elements around IBM's Qiskit works, that's all emulated quantum. So obviously you can go and scale that to a certain degree. It's not a direct one-to-one qubit like equivalent of physical, but that's where, we've now just recently released our 10-year roadmap, which includes us progressing from not just emulated quantum and quantum annealing, but also physical quantum. So we've already started the process of patenting the technology. We're already working with manufacturers to actually build a full-scale home quantum processing unit that should work just as an add-in card, basically, and will allow quantum processing to be done. Now, obviously, that right now, most people wouldn't be able to take advantage of, right? It's going to take time for adoption, and ultimately, we've got to get out more documentation around the QPU once it's available to the general public. We've got to then look at where that lies, right? From an ethical perspective, from a cost perspective. We want to make sure that if the technology is going to be, adopted fully, we know that it has to be affordable to the everyday person, right? That's something that we've fundamentally said since day one. Dynex is available to everyone. We want to lower that barrier to entry for quantum, because ultimately, if you do that, you'll now open the door for brand new people that might only have an interest in it, but could be amazing coders in the industry. Problem is, the cost to get involved in that now is just too expensive right now. And that's where we've been aiming to open that door. And, recently as well, we announced a link up with doing a university course for Dynex. So you'll actually be able to register for a proper qualification, comes with a proper stamp. And we hope to make that an industry standard type course. So, long term, we've got a long-term plan around Dynex, and ultimately the blockchain is the immutable part, right? That's to prove the jobs have been run by which client ID, and obviously, around how long that took, the number of qubits, the cost overall, because obviously analytical statistics, right, for how well Dynex is doing, it's coming down to the number of jobs, how long they run, and how much they're making the blockchain. So as long as we have that all transparent, we can basically continue forward.
Clifford, as you mentioned, you moved from or are in the process of moving from emulated to physical, right?
Well, we're not going to move completely away from it. The whole concept is to do both. right? So eventually, if you were a company of a really small company, right, and you're going to grow, then you can effectively grow with us, right? You start at the cheaper end of the scale, which is emulated quantum. And when your service is picked up and you're doing more business, you can obviously scale that up to a much more dedicated solution, which is obviously a QPU or quantum processing unit, and then scale it up infinitely at that point to whatever you need. So we're trying to, it's a bit like how, Amazon realized very early on in that space that if they just allowed scalable solutions that were one click of a button, that people like that idea, right? The ease of use, the ease of just pulling a slider along, going set, and then off they go, and they get billed accordingly. I think, long term, that's where we're going to have the availability, is just scale it to whatever you need, hit go, and away you go. So
Yeah, so it feels like most of your priorities right now lie giving this technology in the hand of the end developers or end users, right? Affordability is one, and the ease of scalability being the second one, as you mentioned.
yeah, I mean, they're two big factors. There's a few other factors that we look at, like, ease of being able to look at our code and understand the code, and the examples that we're putting out are all notated, explaining what each part does. We're obviously working with the university we're working with around this course, obviously has allowed us to understand where those potential sticking points are in our example set. So we're actually in the process of redoing those as well, making those a lot easier to use. And that, those three big parts, I would say, right? Usability, affordability, and scalability. Really, those three fundamentals are where good businesses, do well. If you set those kind of parameters up, they do a lot better than, if you just jump into it without an idea.
Got it. And another question I had to add on it was, as you mentioned, blockchain is just a part of the data immutability setting, right? So are there other projects, maybe outside Web3, who are working on quantum computing on the levels that Dynex is right now?
That's a very good question, right? Because get that kind of thinking a lot is, who's our competitors in that industry, right? If you look at blockchain, there is only us at the moment that are doing quantum on chain, and we're obviously a level or a layer one blockchain, right? We're mineable, so obviously every user that is connected mining, we can utilize those resources to do an emulated quantum calculation. So that could be anything from basic like Sudoku problems, right? So problem solving to maze pathway finding or pathway optimization processes, to now we've obviously got our LLM about to release, which will allow, things like a chat GPT to be trained and things like that. So we're going to very quickly realize just how we're going to have to scale fast. We know that the chain can take it. With our all-time high, we had probably 500,000 GPUs on the network, so we know it can scale. And yeah, like I say, once we bring on the new parts that we announced quite recently, I think we're opening up the doors realistically for everyone. And the blockchain, so for us, the blockchain is 50-50 with the business, right? There's the enterprise customers who are using the service, but we need to be able to pay for that infrastructure. That's what the whole idea of the blockchain's around, is not only to immutably store records for our quantum jobs for an ethical integrity style solution, it's also for being able to pay our miners for that processing power that they're obviously supplying. So that to us is, the whole ecosystem in such is a way that it's designed in such a way that the miners who are on our network get payouts. They're happy. The clients are able to run quantum jobs for a lot less. They're happy. And obviously Dynex makes their cut on the side for doing all this, and we're happy. So, that's the whole concept.
Yeah, positive sum game for everyone. Tanishq, would you like to ask the next question?
Yeah, sure, Sahil. So I was just, concentrating on how Clifford mentioned that Dynex is for everyone, right? So let's go back to the basics because obviously most of the people watching this video, or maybe when it, gets rolled out, most of the people, I hope they're not much aware about what quantum computing is at the basic of levels.
Sure.
So neuromorphic quantum computing, cloud, quite brainy phase, right? So for me, of course,
Yeah.
it's not that complex. I've gone through a lot of these projects, and like, of course, but for the audience, like, could you break it down, like you're explaining
Sure.
it to someone
Absolutely.
new to everything?
Yeah, I can break this down. So you've got obviously a CPU, right? We know that. That's ones and zeros going at the same time, like back and forwards, backwards, forwards, right? It's single process kind of solution, right? It's ones and zeros going backwards and forwards. Whereas obviously quantum can be both at the same time, which allows you to do, crazy amounts of calculations much, much faster, right? An infinitesimal rate. It's very hard to describe the differences of speed when you're looking at what a CPU can do compared to a quantum processing unit. They're like one end of the scale to the other end of the scale. So imagine you just trying to get something to the end of the line. You got to constantly keep sending ones and zeros, one after another. Now this happens very fast, right? We're at the stage with CPUs where they are crazy fast. So they pump out those ones and zeros really fast, but it's still that chain of ones and zeros that's coming out. Now, multi-threaded brought a whole new concept, which was allowed to, send those ones and zeros over multiple cores, right? But it's still not like quantum where you can go have 500 variables and it just spider webs out from your script, right? And then comes back all at the same time. And that's where the benefit comes in. When you're talking, like, you might have some really, really like complex molecule, for example, right? Now, if you did that on CPUs, you'd have a whole rack of servers, right? Just to do that one thing. One QPU could do the same thing as all of those servers. So the multi part for it, like, think of it like the human brain, because that's the best way to consider what neuromorphic quantum, or just even quantum in general, is like. It's like how neurons fire in the brain. It goes outwards like that, like a spider's web. Because in a brain, like, we know that's one of the most, if not the most powerful computer we know of to date, right? It's the human brain. Its capacity is outrageous compared to a standard computer. Inspiring your system around the brain is actually very logical to me. Why wouldn't we inspire networks like that to work like the human brain, right? You look at neural networks, they emulate the human brain, the same capabilities, the same way that works. Why? Because it's still the most efficient thing we've ever come across for computation. So, for us, so our QPU, our physical, is going to be obviously physics inspired, right? Because what we're going to do is translate what our biology inspired is and stack it on top, right? And then they'll in the microcode that runs the QPU will be a translation layer to take one from the other and the other to the other. No one will ever see that, but basically you've got physics inspired and then you've got biology inspired quantum, right? Neuromorphic quantum isn't a new thing. Neuromorphic circuitry isn't a new thing. It's been around 10 years actually, but no one's really tried it on the scale we have, because the material to actually build a neuromorphic circuit is very expensive. We've come up with a proprietary, almost like alloy, that can allow us to do what we want to do in our circuitry without the degradation. We hope, right? Because obviously you never know till you actually build it. We hope that it will be absolutely what we expect from, what we ran in the simulations. So for us, biology inspired was also always the way to go. But quantum isn't for every process. That's the other thing, right? A lot of people will go, well, can I just switch out my CPU to a QPU and run Windows on it? Well, no. Quantum calculations are done in a very different way than the normal calculations. You're looking at quantum energy ground states and things like that, right? So, of course, it gets a little tricky. To me, it's more like an add-in to a computer down the road, right? We're not gonna replace the computer. We're gonna add something else into the computer to give it even more options available.
Yeah, that's absolutely a nice explanation to that. And also, I was going through your Dynex's YouTube channel, and it also had this documentary on Dynex where they like explained the transition from the analog computers to the digital computers, and also like the next leap onto the quantum computers maybe in the future. So, what do you feel? Where are we near to that crossover point, or is there still a lot of time to go?
I think we're probably a good 5 to 10 years away from the full crossover period where quantum is so adopted that, you know, it's in every household. We really truly believe that that's where it will go, where you'll have a little microprocessor acting as a CPU, and then you're going to have a little processor next to it, looks exactly identical. The only difference is it's designed to run quantum calculations. And these things will work together to be able to speed up the ability for the CPU to actually do things even more efficiently. There's possibilities that are endless when it comes to looking at what CPUs and QPUs could do together. Like hybrid models have an amazing ability to be used really efficiently, because you can offload everything that's inefficient on a QPU to the CPU where it would be efficient. And then you offload everything that would be on a CPU that's inefficient to the QPU where it's efficient. And it just makes it an overall option. We do a couple of hybrid examples on our GitHub, actually, where it's CPU pre-load or a GPU like pre-compile, and then it offloads directly to do the heavy compute on Dynex, and then comes back for the render output at the end of it. So those will be the stepping stone. I can see it being a hybrid model first, and then it will go a fully quantum sort of solution. But yeah, I think we're still 5, maybe 10 years away before we really see the mass adoption of it.
That really makes sense, because when the processing capability of an ordinary CPU exhausts, right? So then the hybrid model kicks in. So that's actually a nice example.
Because we're going to hit that point, right, where we can't go any smaller. We can't put any more power through it.
Exactly.
I mean, we're already seeing GPUs require over 1,000 watts of power just to make sure that if it spikes, it's not going to cut your machine off. Like, that's crazy. Even to this day, right? Why, when we're all looking at saving money, why are we, pushing more power through a GPU and making it ridiculously, powerful? That even means we've got to go even bigger on the PSUs, so that 2,000 watts is going to be kind of a standard. Or you're getting to the point where you're actually double stacking PSUs and you're just having a dedicated PSU for the GPU, and that just makes no sense to us, right? We think we can really get down the average wattage on our QPU as well. We're going to head towards, if we can get it 100 watts or less, I'll be super, super happy with the first version being 100 watts or less.
That's absolutely a great quotation, I must say. Like, if we cannot go any smaller, or if we cannot push any more energy into it, there's a time we need to take that leap, right? So
yeah, at that point, that's that moment where we've got to go, well, what do we do now? Like, the demand on compute these days is only getting bigger, and the demand for quantum is going up at a rapid rate, to the point where in 10 years it's probably going to be a $4 billion industry, to be quite honest. That's massive. And I've not talked to many companies now that don't have a quantum strategy for what comes next, where they're already researching this kind of things to worry about, from a security perspective. Quantum brings a lot of scary things with it. I get that. As a security guy, as somebody who deals with this side of it, scares the hell out of me at times, right? Because I look at what I'm coding, what it's running, and look at its raw potential and go, this is going to give me a really bad headache in the future, right? Because the people there are going to be companies and people out there that just aren't ready for it. It was like that when it did the big switch over with operating systems and such getting out of date, and then all hell breaking loose for a couple of weeks as everyone scrambles. But I think the best way is to introduce it nice and slowly, start doing that education side and really push in for that education of companies to learn about quantum and the dangers that come with it and what they need to do for a post-quantum encryption. Now, we're already working on something internally. We're working on a new form of quantum encryption, basically, using a multiple dimension key map, which should be really, really safe and secure, but we've still got to do all the testing phase for that. It's way away yet. We're probably a year off from having that available, but ultimately that's something that is a passion of mine, is to try and have a go and showcase what quantum could be good at when it comes to encryption, rather than looking at all the bad side of quantum and encryption. Like, oh my God, is it going to break AES and all of those kind of things? And you think, oh my God, that's really bad. I'm looking at it from the other end of that scale of, well, if quantum can break encryption, can it also do a better encryption and give us even more security, even against quantum setups? So, of course, that's where I'm looking at.
All right, makes a lot of sense. I guess, Sahil, we can carry on with the next question.
Yeah, definitely. I really like the point, by the way, before we move to the next question, about quantum being able to break these encryption algorithms like AES and all. I mean, if that happens, Clifford,
I mean, we're away from that a little bit, right? Look, if you look at the number of qubits like that are actually on physical quantums, we're still a way away, but we should already be looking at that next part now. Because if it's coming in 5 to 10 years, it's going to take 2 or 3 of those years just to develop the new encryption methodology and technology, and then distribute all of the documents to everyone, have it validated, have it, pen tested and everything like that. So it's going to take probably 3 to 5 by the time it's validated before it's even available. So of course, that leaves you 5 years to implement everything. And, most people don't realize this, but there are more equipment and servers than there are people in this world. And of course, it's by a massive magnitude as well, right? So everything would have to be updated. Everything.
Yeah, we can never be too safe with this.
No,
right?
no. It's always worth making sure you look at those next things. As a business, you should definitely be looking at the next dangers to your business, right? That's risk assessment and risk management. So, and as part of my role at Dynex is to look at all those risk management. What's the dangers? So if we showcase one type of scenario, what's the ethical implications? What's the dangers to us if we showcase this piece? But we run a digital fingerprint solution that we've developed in-house. What it does is it takes a look at the code that's being run. Now, it can't work out what you're running, but it can get a good idea based on a fingerprint. Because every job that's run on our network leaves a distinct mark, like of what it's doing. So we know if you're trying to crack a password, it leaves a very distinctive mark on our network, for example. We can block that, right? If you're trying to do something crazy with, prime numbers to go really big, because obviously, RSA requires 2 really large integers, then that will flag as well. Because even though we've done an example of a small set, the fingerprint is very similar, even if you go bigger. So security is one of the main things, and the ethics committee for us, when we start really processing a lot of jobs, they're going to be busy. They're going to be really busy.
That's really interesting. Really, really interesting. The implication, I hadn't thought of them before you started discussing it, to be really honest. We had been under the impression of all the good things. And I think this is what people usually do. We think about all the good things that new tech will bring, but there are parties out there who are thinking of the bad things. So some good people have to
look at both sides of that equation, because
yes.
I've got to try and put a stop to it before it happens. So, that's really, it takes a lot of work, right? We look through probably, 100 requests by the service a week, just where they've been not flagged and stopped, but internally flagged as us to take a look because it's a new fingerprint that we've never seen before. And we obviously have to then debug that fingerprint and see if it's okay. So it's a lot of work. It's a lot of complex code to make sure that it works. But if we don't have that, quantum without any boundaries is a scary prospect. And with the size of the network we've got, it would be highly dangerous. So, we have a responsibility to do quantum ethically.
Yeah, definitely. So, let us get back to the Dynex updates. And I think October has been a really busy month for the entire team. I'm pretty sure of that,
It has.
right?
Yes, it has. I've done a lot of traveling, to be fair. I was recently in Italy at Mugello. That was announced just before the big 12th announcement we did. I was over in Italy at Mugello doing a race simulator demo for actually doing the simulation parts on quantum. We showcased that with nothing more than a laptop and a very non-powerful 2050 GPU. It worked fantastic. Claudia, our other quantum specialist, she was over in Portimao last week, or this week just gone, sorry. And she was again showcasing the next updates that we'd already brought to the race sim, and that was only in the space of like 4 weeks. We'd done a massive upgrade to it, so we wanted to go and showcase it and test run it with live data. So yeah, I mean, that's just one part. Then obviously we got the wrap token. The wrap token launched literally 2 days ago. So that went straight on Uniswap as our first sort of DEX kind of scenario, right? Swap service. It's done all right. We're very pleased that it launched without a hiccup. Because wrap tokens scare the hell out of me, and bridges scare me even more. Because obviously we hear about how many bridge hacks do we hear about a month? It's bad, right? So we made sure that not only did my company, my auditing firm, audit the contracts, we also sent it out to a third party for a really deep contract analysis. Thankfully, they pretty much came back the same with a few tweaks that we needed to do. Ivan, our developer, had that done very fast. And the bridge so far has held up very nicely. And we've even now gone to the point of actually marking that all on our blockchain as well. So any transactions that are going through the bridge will be marked as bridge. So you actually can clearly see how used our bridge actually is. And that's a 1-to-1 bridge, by the way, if anyone's wondering. It's one Dynex in, one wrap Dynex out, minus obviously the transactional fees. But yeah, it's working wonderful. I mean, then obviously the 12th, we had the big QPU announcement, right? That's what we've been talking about most of the time here as well, but that's massive. People don't quite realize just how much of a big thing having a possibility of having home quantum at room temperature, right? For those who don't know, obviously current quantum machines have to be chilled down to literally absolute zero, minus 273 Celsius, I think, somewhere around that. And that requires a lot of liquid nitrogen, a lot of liquid helium. It really does cost a lot of money for that kind of material. Now, if you get it available as like no different than a CPU and you just plug it in, suddenly the door opens for everything, to be quite honest. I really do think. And that's what we were showing off the roadmap for the 10-year roadmap, was to clearly show the progression of where we think over that next, like we just said, about 5 to 10 years, where that transitional period we think will be. So we're hoping to really have our QPU nailed by the time that crossover period happens.
Right. So the wrap token was one of the first things after the QPU announcement, obviously.
Sure. Yeah, the wrap token was the big one that everyone was expecting.
Yes.
The QPU was a complete left field that nobody knew about. There was only maybe 5 staff in the whole of Dynex that actually knew it was coming, because we had to keep this thing under wraps, because until patents were put in and locked in place, we didn't want to talk about it publicly at all, because we don't want somebody getting the jump on us, right? We've got our technology we've built. We want to make sure that we have the chance to protect that option before anyone sees what we're doing. So now we've got it locked in. It at first it wasn't necessarily going to be part of the presentation until they gave us the paperwork and said it's locked in, it's available, your patent's now pending officially. Now nobody can do anything similar. That was when we announced it. So yeah, it was a big day, but I'm really glad the wrap token went well, because bridging to other networks is a great thing, right? From a liquidity standpoint, from bringing on other people that haven't even seen the project yet, right? But they're also extremely difficult to make sure they work correctly. It takes a lot of testing, a lot of revisions of code. We went through probably 20 to 30 revisions of this code to make sure it was sound, that there couldn't be any issues or breaches. So we've really done our job and due diligence in that.
Yeah. So just this question after this, what is up ahead after the wrap token? What is the next big priority for the team?
So going into the end of the year, and obviously what we've got planned for next year. So next year we're going to start scaling up, going to all the different conferences. We've got a team of people that will go to the business side conferences, and we've got a team that are going to be going to all the crypto conferences. In March, we're doing our very first full sponsored event. So that's Web3 Global's conference in Amsterdam. We're actually, I'm going to be speaking on stage with our co-founder, Danny. We might even have our head of business strategy there as well, Carsten. He'll probably be up on stage as well. We're going to have everything we can, including, if it's available, Unitree have yet to tell us a dispatch date, but maybe a quantum-powered robot might be there. We announced that we were going to do a try and see if we can integrate Dynex into a robot for reinforcement learning. Unitree have got a full humanoid robot that uses reinforcement learning to physically learn what it's done each day, with the idea of being more and more, like what you'd expect from a humanoid robot. We think we can help them a lot because we can do a lot of reinforcement learning using Dynex. And we know that works. We've got other projects and applications that are currently using that technology on the network right now. So we think we can use it. It's just at the moment the robot isn't available yet. We've already pre-ordered it, our robots. If we get them done, they'll be there. I might even see if I can mock them up to look like a Terminator just for the fun.
Now, this is something I'd really love to see. Maybe not in Amsterdam directly, but maybe on the internet, for sure.
Yeah. Oh, yeah. We'll be taking. Don't worry. There'll be tons of promotional material we're going to be doing around that. Right. We're going to be taking photos, videos. We'll have people recording all of our on-stage presence, because ultimately that's going to go all on the YouTube, right? All on the social medias. We're going to blast that out hard over the time, and there'll be other projects as well that we've done X Spaces with that are also going to be there. We do a lot of X Spaces with Porchain and Etherland and a few others quite frequently for in Web3 Global. So they're also going to be there. So there'll be probably quite a lot of social media going on at that event. But that's not just the only thing, right? We're going to be booking up the whole of 2025 events to go to. I'm going to try and be I'm going to do a lot of miles next year, even more than I've done this year. And that's a lot. So I think I've done 4 trips to America, a couple of trips to Dubai. And then obviously we were jostling around with QPU and other things, but we were booked in to do Singapore, Japan, and a few others. So I've got a feeling that I'm going to be getting some fairly large air miles next year.
That's amazing. I would be, like, we would be looking forward to that, like meeting you IRL if you like, if we
Yeah,
are at the
absolutely.
same
If
event
you guys
someday.
are
Yeah.
anywhere where we're going to be, then yeah, absolutely. I mean, we do Dubai a couple of times a year easily. If you guys are near Dubai at some point, let us know. Obviously, we do a lot in Europe. A lot of us are based out of Europe. Got a couple of staff over in the States now, and we've got some of the developers are over at Hong Kong way. So we really do have a global reach of staff right now. It's why I always say Dynex never closes, because we don't. We've always got staff on whenever there's a moment in time. So for us, that's one of the reasons why I think we just are able to iterate so much so fast. It's just because we don't close.
That's absolutely amazing. I mean, if someone from the team is always up, that's always a good factor. That's what we try to incorporate at our company as well. It's like, just because of our different sleeping schedules, we managed to do that as well. So our crypto talk is always
Yeah.
live. So that's another thing. So yeah,
Yeah.
we've talked a lot about the documentaries, the analog computers, the digital computers, the mass adoption of PCs with Macintoshes, with upcoming neuromorphic computing and all. So we wouldn't like to take much time of yours, but then there was one particular thing that I was, kind of pretty interested in, which was Dynex's partnerships. So given that the compute power is a space with, I'd say, tens of Web3 projects, right? Not in the quantum compute space, but in the broader umbrella, right? So I saw your partnership announcement with Nuco, and Nuco Cloud guys are like great friends of ours as well. Tobias has been on our podcast too before. So how do you see this
Yep.
part of the business? Like, how vital is it to form partnerships in this space?
Yeah, I mean, so we've got a bit of I would say people might call us a bit picky when it comes around to partnerships, right? We're not about paper partnerships at all. I hate seeing it with projects, right, where they announce 50 partnerships every week and nothing ever comes of their partnerships. It's just a paper partnership for namesake. Whereas our partners are actually going to be doing something with us and us with them, right? So our first partnership was Octaspace, right? We've got 3 partnerships off the top of my head when it comes to crypto ones, right? We've got Etica, which we donated some medical research computation to as part of the agreement. We've got Octaspace, who are our partners. We do a lot of work together. We help them with their bridge. We are able to combine a lot of knowledge of rendering side of things and heavy compute from that perspective into quantum. So they're able to really go both ways. We deployed a actual Docker infrastructure to Okta, so you can run Dynex SDK with a full lab environment, all pre-set up for you. That's deployed on Okta. And then obviously you got the new partnership, or it's more of a reseller partnership agreement where Nuco is going to offer quantum services powered by Dynex. So we got the one end of the scale to the other for the partnerships, right? One that we believe in, which is Etica, because they're doing medical research, right? And medical research on chain. If they can make use of the quantum, fantastic. It's there for them whenever they need. Then obviously our partnership with Okta, which is more around infrastructure, right? And then you've got Tobias and Nuco, where they're bringing on equipment or they're bringing on customers, but ultimately they're reselling Dynex as Nuco services, which is fine. We have no issue with that, actually. We think that's a fantastic way to introduce new clients to us via those reseller partnerships. And we're looking at onboarding a few other ones as well that are going to do that reseller kind scenario where they will bring us clients. They effectively have an arrangement and they can sell it as their own quantum services, just powered by Dynex. But yeah, the guys over at Nuco are nice. I speak to them quite frequently, actually. I think last call with Tobias was a couple of weeks ago. So yeah.
That's nice. And the best part about what you said was, what I felt was that people in crypto, just do partnerships for the sake of it, but you're very choosy and very picky with those things, and that absolutely makes sense, because whenever I go through X, I see multiple projects doing partnerships every day, 3 partnerships a day, and I don't think so they even like do something behind that. So that's great.
Yeah, it's for me that's not good business, right? Because first and foremost, Dynex is a business. If we announce partnerships, they've got to be fundamentally right for the business, because anything that we agree on a crypto side actually impacts the business, right? So we've got to look at it from both aspects, whether it's good from the crypto perspective and whether it's good from the business perspective. So we always are very, very choosy around what the partnerships are, what we get, what they get. It's got to be a two-way thing, not just let's put a logo on a website and say we're partnered, because that doesn't work for me.
I think I discussed this with Nathan as well before talking to you, Clifford, that I've always been baffled by crypto projects forgetting that they're a business too.
Yeah. A lot of the time people think that crypto projects have to become a business, whereas we're doing it the other way around. Yes. We are a business with a blockchain. Right. It's very different. We go in with a business mentality. Now, all right, that means at times we have neglected at times, I would admit, the crypto side, right? But we're trying our best to balance this, right, as best as possible. It's not always easy, because sometimes some of the higher up staff are needed on business calls when you need you might be talking with a new crypto project that needs some help, kind of thing. So sometimes there's a bit of a clash, but so far we're managing pretty well to try and even this back out. So we heard all of our community saying that they wanted to see more of us in the crypto side. So that's why we brought on a few new staff with a more crypto background rather than just business. Thankfully, there's 3 or 4 people high up in the staff that obviously have a very good business and crypto background. But obviously, if we're needed on business, we're needed on business. It's sometimes a struggle, but we're working on it. We're working.
I think it's a struggle, but it also allows you to bring the best of both worlds. As you mentioned, paper partnerships, something I and Tanishq, we talk all the time, like, what is happening here? They just announced
our partnership with Okta has been fantastic. Like the conversations with Tariq about what Okta's doing. You guys should reach out to Tariq and have a chat with him. He's a fantastic guy. And what Okta's doing with rendering is outrageous compared to some of the other projects that claim to be, decentralized rendering. I won't say names because I know that'll only stir the pot even more, but there was a video released on their X account that absolutely smashed the biggest render platform going by some considerable margin as well. So yeah, like I love Tariq. He's like me. He's like, I don't need to say anything. I just post the proof, which is very true, right? You if it's fact, you can't dispute it. Like if people can replicate that as well, then it's undisputable, right? Because they can replicate the exact same result.
Yeah, definitely. The proof of work, as we say, right?
Yep. Or as we call it, proof of useful work, because it's actually doing more than just block hashing, right? Definitely. We're not just talking about validating blocks and validating transactions. We're talking about more. And considering that the GPU for most algorithms is barely even used, right? The mining algo itself might only use 10%. What a waste to leave 90% on the table. Why can't you make use of that for something more useful? Like, we see it with other products and projects. Like we've seen recently Claw, Flux. They're all heading down that decentralized compute avenue, right? Flux was one of the first to really start with the POUW term and really push it. We were the first out the door to actually have a practical application of POUW. But our implication, and say somebody like Flux or a Claw or an Okta or all these other type ones, they're all very different. They've all got sort of like a little different spin on it, right? Us with quantum, Okta with rendering, Flux with more of a a unified solution, right, for more like a web host infrastructure and decentralized apps. Then you've got obviously Claw, which are more rig rentals and that kind of thing. Everyone's got their own like unique spin on proof of use of work. And I love that because proof of use of work is just a term. It's not any one person or any one project's right to say they are only the POUW network, right? Because POUW encompasses a lot more. It's just doing more than blockchain.
Yeah, like to be honest, Clifford, I have a huge list of questions I want to ask you, but as we're short on time, like the way you mentioned, proof of useful work, Dynex solve, and the way your white paper, starts with the ends of Moore's law. It's there's a lot of things because obviously quantum is a very large subject. Like we cannot go about everything. So that's more or less. So from my side, I do have
Well,
something.
we can always do another. We can do a part two if you guys fancy a part two anytime. You just let me know. I enjoy
Absolutely.
just chatting about what's coming and what quantum can bring to the table. Because the more we educate people about what's coming, the easier it is to adopt. That's ultimately my biggest goal, right? In doing all the interviews and meetings and up on stage talking and going to Bloomberg and sitting in front of 15 recording devices, and like all of that leads to just better education. The better the education, the more people understand it. The more people understand it, the more adoption comes. So,
Yeah,
and that's
definitely
not
we can.
dissimilar for crypto. Actually, the more education people have been getting, the more adoption rate crypto got. So it took a bit of time, but we're not in any rush. We're fully funded. We're fully self-funded, actually. Although we took a small VC round recently from Victor's Capital, the reason for that was so that they can help fast track our tier one exchange listing. So obviously, what does fast track mean? Fast track just means that they've got somebody that they can make, an introduction to us and get us our foot in the door kind of thing. So for us, fast tracking an L1 is a T1 exchange is important. But it's also important that people realize integrating L1s is not as easy as integrating an L2 with a contract. Exchange only has to click, add contract, and wham, L2s are added immediately. And L1 takes a bit more time and a bit more in-depth conversation and backwards and forwards. And never mind the costs of listing on these places, right? People don't realize to list on Binance, you're looking at $1 million minimum just to list. That's crazy. Like, new projects, small projects, like that's hard work to be able to list on places like that when you haven't got that kind of collateral. We're lucky. We are okay. We could. We just need the way. We just need the go aheads from these exchanges to say yes, we want to list you, and we'll be good. And that's what Victus is ultimately there for, to help drive that part forward for us.
Yeah, we would love to do a part two with Clifford. As Tanesh mentioned, this is too big a topic, too complex a topic.
Yeah, I'm always used to doing a part two with most people that, you end up having, say, 10 questions. You get to the end of that, you have 20 more.
And as we were discussing on text as well, maybe you showcase us some of the demos.
Yeah,
or some
absolutely.
things that you have.
I've got plenty of showcase pieces that I can definitely show you guys. That would be really cool to show you and walk you through the process of what it's actually doing at the time, right? So we got a few different ones from like a multi-vehicle routing problem. So take X number of vehicles, X number of locations. Here's all the materials, distribute them evenly over X number of locations, making sure that every vehicle doesn't do more mileage than anyone else and that it's all equal, right? And that's quite hardcore computation to figure that all out, especially when it's taken into fact of road speeds, road length, direction of traffic, how heavy that traffic normally is at that time of day. It's a lot of data. It does it really fast. When you do the pre-processing and upload it to our server and it gets processed, it comes back within like maybe a minute. That's just unreal speed compared to what you'd do if you did that in a CPU. And then scale it up. Now do 1 million vehicles with 50 million locations. Now you're getting into the realms where CPUs won't even be able to keep up. A quantum machine definitely can. It's going to be a big calculation, but ultimately it would work. So, but yeah, I've got also, if you're into sci-fi, we took a research paper for Alcubierre's warp drive. The actual physical white paper, we wrote that out into Dynex code and actually was able to simulate his warp scale that he worked out and have it in real time work. So that was pretty cool. Obviously, the race sim is a big one. I could probably showcase a bit of the race sim. That's actually never been shown yet fully. We showed a few clips of it, but never really like fully demoed of what it can do. But yeah, we got like really cool stuff. If you're into like sci-fi and space, there's a few pretty cool showcase pieces. Star cluster age classification is pretty good as well. So take a big image from, say, James Webb and work out how old every star is in the picture. Takes 30 seconds. Just incredible.
Yeah, we'd love to see all of them, wouldn't we? And
Absolutely.
I think the audience, even I don't think not on our channel at least, has anyone seen such kind of showcases and demos. So we definitely love.
We always like showcasing stuff because visual learning is sometimes a lot easier for people, right, than just hardcore reading. I can understand that. I can understand that. And you know, visual learning is much easier for that kind of scenario, because trying to explain to you what star cluster classification is very difficult to make it easy to understand. But if I can just run the simulation and show you it, then immediately you get what I've been talking about. So yeah, I'll bring all of the showcase pieces, and you can let me know which ones you want to run, and we'll do a proper demo for you.
Yeah, for sure, Clifford. I mean, to be honest, like I'm not just saying it just for the sake of it, but I really have a lot of questions. Like the way you mentioned, you come up with 10 questions, you have 20 more in your mind. So it was an absolute pleasure talking to you. It was overwhelming as well.
Absolutely. Nice to meet you guys.
Yeah, so like we have come a long way from UCL's mechanical brain to Dynex in 2024. So a long time. So yeah, thank you, Clifford, for joining us today and sharing such valuable insights into the world of blockchain security and quantum computing. It's been an absolute pleasure hearing about your work with Dynex and the exciting innovations ahead. We look forward to seeing more from Dynex's growth and success in the future. And thank you again for being a part of our Crypto Talk.
Thank you for having me.
Thank you so much.
Absolute pleasure.
Take care.